Welcome to AI in Design, where we explore how artificial intelligence is reshaping the world of design. I'm Dan Saffer.
And I'm Nick Martellero, and we're faculty at Carnegie Mellon's Human-Computer Interaction Institute. Each week, we break down the latest AI developments, dive deep into topics that matter to designers, and talk with fascinating guests who are right at the intersection of these fields.
Whether you're a designer working with AI or an AI practitioner interested in design, we're glad you're here. And what an episode we've got for you. This week, we're going to spend the entire episode breaking down in minute detail the design of Johnny Ive's new EV Ferrari. No, actually, we're not going to do that. We're not going to do that at all. We're actually going to talk about some new features in Figma Make and Google Stitch.
Then a new article by Romina Kaucic that asks if the real value of design systems in the era of AI is actually memory.
And then we'll have a little amuse-bouche for us all, a site for genius founders to make bad design decisions and generate irredeemable amounts of technical debt.
And finally, this week's special guest is the CEO of Quilter, a company that builds AI-driven software tools for designing electronic circuit boards. This is basically the Figma Make of printed circuit board design for all kinds of electronic gizmos and gadgets.
Sounds pretty cool. Okay, so let's get into it with some updates from Google and Figma around some of their tools. So the first is Google Stitch. Google introduced several new updates for Google Stitch at their big annual conference, Google I/O. These updates are focused on real-time collaborative design. So some of these new features are real-time streaming and generation. So Stitch can now stream its design work straight onto the canvas, and it lets you basically watch the AI build and reflow your ideas in real time. Then there is the Stitch Agent. You can experience a live collaborative partnership with Stitch Agent, sort of like Figma Design's agent, and we'll talk about the differences in a second. And it really allows you to steer your iterations and make the changes before the final product is completed. They also go into some natural inputs, so you can interact with Stitch using text prompts or voice commands. You probably like that, Nick. Uh, you can also seed your design by bringing in an existing code base or existing design files. And then you can do some studio integration. You can generate a shareable preview link via Google AI Studio. And then you can do some exporting upgrades too. So you can export the completed screens into Google Anti-Gravity, which is their big agentic platform to easily connect and plug into your backend logic. There's Netlify integration. You can publish your work directly onto the web using Netlify. Now, like I said, the Stitch agent's a little bit like Figma's design agent that launched 2 weeks ago. There's a couple differences though. Stitch focuses pretty heavily on rapid prototype to production deployment, while the Figma's agent feels like it's more about deep integration with established design systems and file maintenance. And to me, Stitch still feels a lot more like a prototyping tool. It's got this immediate end-to-end execution. You prompt it, you get a responsive layout that can be exported to backend tools or deployed straight to a live URL. Meanwhile, I think Figma's design agent feels like it's much more for power Figma users, and it works within a complex, established enterprise brand framework. And it uses the intelligent agent to understand things with a lot of precision, like your design tokens, and it's managing things like your layout, and it's trying to do a lot of the bulk UI maintenance tasks that eat up a lot of time. So that's kind of how the difference is feeling to me right now. Nick, I know you tried Google Stitch a little bit ago and did not have great results.
Yeah. So I tried it and I used their sample, which was generate a website for a hotel in the Muir Woods. And I thought it actually did a good job at generating the full website. It picked a pretty nice color palette, good typography. I mean, it looks very much like you would expect a modern site to look. for say luxury hotel booking, but it was honestly it was good. I liked it. And then I wanted to make some small changes, these sort of precision edits that I think a lot of the changes that Stitch is trying to make are kind of addressing. So the ability to kind of go in and say, change this or add a comment or annotate something. So there was a button on mine which was see-through, and I was like, this button really ought to be white so that it has contrast and you can see it. Real simple thing. And think with something like Figma Agent, you'd be able to go in, leave a comment, and then would update. Same with Claude Design. I've actually been using Claude Design a lot, and I do that now all the time. I throw down a bunch of comments while it's like working. So I did that, and I couldn't make the button white. And I tried again. I tried using the annotation feature. I tried using a comment. I tried just prompting it. I tried switching from Flash to Pro, and it kept saying it was doing it, but it never changed it. I never saw the little cursor go. Finally, I did say, hey, just make me a new version of the site, but where the button is white. But then it broke the reserve your stay button, which was a nice green, and made that white with white text. And now you couldn't see it. So there's still some rough edges here. I'll say the design sense, the overall design sense, and I think what's probably in there in that design MD file is pretty good. Like I personally find aesthetically and from the layout perspective, like this is pretty good. And I think that if you were someone like a Google Workspace customer and you use this for a small business and you need a website, I could totally imagine, using this in the future where you just use Stitch, you put together your stuff, you edit your content, it builds it out. And then you have, maybe a management system the same way that you used to build a Google site. Like I could see where this is going, but this definitely isn't a production tool as of yet from what I can see.
At least not for designers. I mean, this is still in labs,
Right.
so it's still technically a beta product that it's just there to be played with, with by people like you and me and our listeners. So it's not ready for prime time yet.
But again, I think as like an alternative for design exploration, I mean, I find myself these days, I jump back and forth between different tools just to almost be like, oh, let me get a different perspective because a different tool may do this. I'll say I really do like their design system creator. Like it does create a really nice thing of like, here's your colors, here's your 3 typefaces, here's what the buttons. And honestly, that ends up usually being pretty good. And I can totally imagine taking that and then bringing that into any other tool that I want to use and saying, all right, we're going to work with this now.
Yeah, it's a fun thing to do when you're run out of credits on one platform to jump over to the other and be like, okay, let's try this over here.
I'm sorry. Yes, I mean that actually is in many ways too. When I talk to people, that is often when they start to switch, is they run out of credits on something and they're like, well, let me go try something else and use up my credits there. And so yeah, so I definitely think I think the Stitch team is doing a great job in regards to like quickly adding features. It's still really impressive to see the tool that they've built compared to say a Figma. And in the same way, right, like this is now becoming similar to Claude Design. These non-design software makers are now making what I do think is going to move towards pretty solid offerings, at least for a certain set of clients.
Yeah, I would not count Google out. If you have everything integrated with Google in terms of like the Google Workspace and anti-gravity and all these things, like, yeah, having Stitch there as your design partner to do these little things makes perfect sense. So, yeah, why would I jump out to Figma or Claude to do this when I could have it right there and make changes pretty fast in the suite that I'm used to working in? Okay, so that was what Google announced, and then Figma also announced something new. Again, they are trickling out the news before their big conference
Yeah, I was gonna
in
say,
3 weeks.
they're kind of just like putting little teasers out. Last week we had the design agent. This week we've got Figma Make now being able to edit your local code. And so what this means is that if you have a code base that is under version control, say with Git, you can get that code locally, you can check it out to your own machine, and then Figma Make will actually allow you to work on that, make changes, make edits, and it will push those to the local branch of your code. What that means is then you can submit pull requests. You can basically push that back upstream to your developers to then review and then integrate. And in many ways, right, this feels like the dream that I think you've mentioned before on the show, Dan, which is like the ability for a designer to actually pull down production code, say, there's something wrong. I'm going to just make small changes. And this is something that Figma is really putting a lot of effort on is precision changes that a designer might want to make. And then it's edited the real code and then you push that back up and then it goes through whatever, approval process, but basically you can make the change eventually to production code.
Yeah, I mean, anything for me, anything that makes that transition from a Figma or a canvas or something visual that I can be editing and then sends it away to do its magic thing and go up into production and just be built. That to me is incredible. I love that. It is great. It is the dream where you don't have to be messing around with things like GitHub and stuff like that. I just don't want to have to deal with that. I want my agent to deal with that. That's why we have agents now, right? To deal with
Yep.
these kinds of things. I want that to happen. And maybe that makes me a bad designer in 2026. I want somebody else to handle some of that transition for me. But I think that that is a major hurdle to overcome. Once it is overcome and it's extremely seamless, some of the people that have been hanging back may really get into this.
Yeah, one of the other things too about how they're designing this is that you can take screens, components, pages from Make, and you can copy and paste them into the Figma canvas. So let's say because one of the things to remember here is Make and Canvas are different. Make is actually editing code, whereas Canvas is still the drawing tool. It's not actually the code. But you're able to copy from Make into the canvas. You can then use Canvas to do direct editing, or you can work with the Figma agent where it's editing the canvas elements. And Figma now will detect the changes and it will prompt you to bring them back into Make so that you can make the updates to the actual code. And so this closed loop is actually, I thought was really interesting because you could start with code in Make, maybe make some changes, realize, hey, I want even a little more precision. I want some finer control, or I just want to work with this. I'm going to pull it into the canvas and be able to do that. But reminding you, hey, you made these changes over here in Canvas. And I could imagine this can be really great for the whole organization because then if you're a designer who isn't using Make, if you're not using code at all, eventually the Canvas agent will be able to have a sort of understanding of, hey, this is different from production. Is this ready to go? Should we ship this over to actually be put into code? Without needing to say, have the designer remember or have the designer say, I'm going to call a meeting. Here's what we're doing. This can all kind of happen in a more automatic way. And so this is kind of the vision that I feel like this is where Figma's going with stuff is to be able to have this really closed loop interaction across all these working methods. One thing to note, and I think I might have missed this on the announcement last week because we were saying how we don't have access to this feature because these are rolling out in betas, actually as kind of rolling betas for select users. And I did find finally at the bottom of this article that the new capabilities, including direct editing, annotations, chat, PR creation, all this stuff it launched on May 28th, but you have to sign up. So you can't actually even just wait to expect maybe I'll get it eventually. You actually need to go sign up. You'll get on a waiting list and then you'll be able to potentially try these. One of the other things that they note is that it won't consume any of your credits during the beta. And they expect to announce AI credit pricing in the near future. Maybe we'll hear about that at Config. Maybe we'll hear about that later as they learn how people use this and how much they're doing. But this is a really interesting point because you can try it now and you have no idea how much this stuff costs you. And this is something that we see in the news more and more about how teams are starting to realize how expensive some of the AI agentic code development and editing is. And so it'll be interesting to see when pricing does come out. Will it be affordable enough for designers to do a lot of work with this? Or does it end up being I don't know, maybe we'll use it sometimes and we have to think about how to ration it?
Right. That is a big unanswered question that is going to happen across everybody very soon. As soon as these tokens stop being so subsidized.
One thing that I imagine we might see is that tools that have integrated AI where you're using their credits to do work. And who knows actually what backends they're using. They could actually be using a variety and they're probably making deals. They might even be using their own models that they've fine tuned. They actually might have better pricing because they have a better understanding of their own tooling and what's necessary, such that they can actually provide the right context, the right tools, the right way for an AI to interact. So one thing that's interesting here might be that using a general purpose agent like Claude or OpenAI's ChatGPT with Figma via the MCP could potentially be really expensive if you're paying per credit with those tools, with those systems. Whereas Figma might actually be able to design their systems to be a lot more efficient in their token usage, and thus it actually may be fine. And the pricing may look like, we can just do monthly based pricing instead of token based pricing, and you will be okay. That being said, I feel like a lot of companies are going to start moving to token based pricing. And so you pay for what you use.
Then is Claude Design going to be like, well, we're going to optimize Claude Design to use your tokens, so we're incentivizing you to stay on Anthropic platforms versus going out and using Figma. So yeah, we could start to have the token wars. The token wars have begun. They have, or whatever the Yoda quote is. Clearly, I still think that these rollout strategies are a way to keep Figma in the conversation, even as all these other advances are happening, even as Stitch is coming out with new stuff, even as Anthropic is coming out with new stuff. Because I'm sure they probably wanted to save all this cool stuff for the conference, but 3 weeks is a long time in AI time now.
Or we're going to see even bigger announcements on stage.
Or yes, or these, these are the appetizers before the big reveal. We shall see, and I will see in person.
So, talking actually about token efficiency and token usage, the next story that we wanted to discuss was about the design system advantage being memory as opposed to being, say, the tools or the processing. And this is actually something that I think relates well to some of the conversations we've had around context management. So the author argues that the true advantage of a design system in the era of AI is organizational memory and not the specific AI models or the tools used. Actually, the design system and the things that are associated with that are portable. Those live within your organization, and you could use all kinds of tools for it. You could say 1 week use ChatGPT, the next week use Claude, then move over to Gemini. Who knows? Play around with some local models maybe as those start to get better. One of the things that's discussed in the article is that often AI agents can actually easily read the visible aspects of your design system, your tokens, components, any formal documentation you have, the Figma files now, but they still don't always work that well. And so there's a question as to why. And one argument is that they struggle because they lack access to the invisible 90% of the rest of the context around why these design decisions were made. What patterns were rejected, what patterns were selected, and why, what were sort of the historical trade-offs that were discussed. And this information is often not embedded within a design system. This is the design rationale, but design rationale is often not documented because we typically are moving so fast that we don't write these kinds of things down.
Or it's just a tacit skill, right? Where we're like, oh, well, of course, this piece goes there because it always goes there. But that's a connective tissue that you learn from experience or from working on a particular product where, like, yeah, we always use a carousel at this time. We don't use a scrolling list. We save those for this thing. And that is stuff that is not typically written down in a design system.
It might be written down though, or at least have emerged somewhere in, say, like a meeting. It could be in something like a Slack thread, email threads, who knows. And actually today, because we are often using more digital communication tools to do this kind of stuff, we actually might be able to access some of that rationale a bit better and then create the documentation that's necessary for an AI system to work with it better. So if it is in Slack threads or Figma comments, in theory, you can actually capture those. There are some systems out there that maybe help you do that. You could copy and paste stuff when you know you've made an important thing. Ideally, you'd want to automate that. And then even things like in a meeting, actually, a lot of times people are recording meetings now so that you can have like a Zoom or a Google Gemini transcript afterwards. And it's helpful. People are finding a lot of value in the recording. And what you could do now is you can actually utilize systems, likely an AI system, to process those meeting notes, process those Slack threads, to then generate the design rationale and documentation that you can then provide alongside the design system. Now, there's a lot to do there in regards to making sure that that system is set up, making sure that the AI systems have access to those documents. And the article does go into a couple of tools. Actually, there's a cool tool here called Query Markup Documents, or QMD, which is a way to take your local documentation and then make it more accessible to AI. It's actually a cool open source project. I hadn't heard of this. I'm actually excited to try it myself. So that's one way of doing it. I'm sure there's going to be all kinds of companies that are going to be providing products for this in the future. We might even see this in products that like Figma. I could see this being a big value of saying, well, they already have all the design system stuff. How do you capture some of the rationale in that? How do we basically integrate that information so that then the Figma agent works better? And that could be a big differentiator of how these systems actually get much, much better from where they're at today. Like, I feel like we've hit a pretty good, at least for web design and mobile, pretty good. Yep, I can work with it. I can generate reasonable design. I still got to steer it a lot, and it still does all kinds of stuff. And I'm like, no, we don't do it that way. Or, oh, I got to do it this way. Having access to these memory documents and this kind of rationale, I think, is the thing that may set other products apart as they incorporate these in a better way.
And this to me seems like yet another place where design ops can grow into, where if you have a design ops person who is sitting in these meetings or taking these meeting notes or helping to process these meeting notes or working with different designers and crits, they can be the ones that are creating, managing, and feeding and testing all these design instructions or annotations or connective tissue between all the different pieces of the design system. Design ops was always meant to help scale design, and now this will make it easier to scale design across the organization for when someone who isn't trained as a designer is trying to make something or build something or tweak something. Be like, hey, wait a minute, we only use carousels for this. We don't use scrolling lists. Please stop trying to put a scrolling list in here. Please use a carousel instead. So I think, yeah, this is just another example of where that role could be playing a bigger part. Our last news story is pretty silly. It is a website called Fraude Design, and it's an AI-free site builder for, quote, genius founders. It takes your bad design but makes it even worse. It brings terrible design decisions and tries to gaslight you into believing that the thing that you made is actually pretty good. It is doing this without AI, so it doesn't have all those crazy token spends that everyone else is doing. It's well worth their time to go play with Fraude Design. There's a lot of really good profanity here that we would lose a not explicit rating to start talking about, but you should definitely explore to derive your own useless slop without the AI. Nick, you like this though.
It's funny because it's intended to be a parody and a joke of AI or alternative AI free site builder, but it is actually a functional basic site builder with a few blocks of like cards, carousels, accordions. You can change your colors for a number of things. You can change I think it's mostly color. Yeah, it's mostly color and stuff, but it's not that bad. And the site itself doesn't look awful. I mean, the funny thing is it looks like every AI generated site that
Yes,
you see.
yeah, it's really if he didn't use AI to do this, he did a really good job. And the auteur behind this is a guy named Scott Riley.
But yeah, I mean, so it's funny. I mean, actually, there's a little thing at the bottom that says, "How does this work?" And it works with declarative UI, and it's just rendered. There's a bunch of stuff in the background where it knows what these things are and puts them in as, in this case, svelte objects. But yeah, it actually like works, and this is something that I feel people still miss. Like, there's all kinds of template building, and there were plenty of companies that helped you do this. I mean, the funny thing here is that to me, it's less about, oh, you can't build a product. There's no interactivity. There's no product here. You can just build a landing page. So as a landing page builder, I don't know, wasn't so bad. Come for the jokes. It's more about reading the ridiculousness here. That's really what is funny about this. Nothing more than that.
Stay tuned for Nick's interview with the CEO from Quilter coming right up.
So now we're here with Sergiy from Quilter, and Quilter is a company thinking about how to apply AI to electronics product design. Sergiy, tell me a little bit about what Quilter does, and maybe describe the way in which it's supporting electronics designers, how that sort of relates to the kind of design we often talk about on the show, which is UX and experience design.
Yeah, Nick, thank you for having me. So at Quilter, we focus on making circuit board design go faster, right? So circuit boards are those little green things that you'd find inside of a computer, like a motherboard or inside of a phone. They assemble thousands of chips, of individual components that then do some sort of function, like drive a screen, drive a motor, have a sensor, things like that. In this process, there's a whole bunch of manual effort that happens. In particular, when you actually look at the motherboard, a human decides exactly where every chip goes. A human decides where to draw every single wire. A human thinks through all the physics of how that board is going to work and hopefully tries to get it right. And it turns out that for decent sized boards like a computer motherboard, that's a manual process that takes many months, 3, 4, 5 months at times. And so we try really hard to squeeze that down as much as possible so that hardware engineers can iterate much faster and get their products into their hands physically as fast as possible. So obviously there's a lot of parallels to kind of more traditional UX design here, both from the perspective of, well, first of all, how do you make a UX for some tool this complicated, with this many constraints, this many things to consider for the engineers? How do you retain control for the user while also doing automation? That's a really critical kind of balance there. But second of all, it's even just kind of geometrically similar, right? Like what I imagine about a lot of design is that you have to have a lot of structure. It has to be readable, understandable, self explanatory. It has to be well segmented. People also like symmetry, and there's always kind of a function that inspires the form, right? Well, electrical engineers think like that as well. Like as in electrical engineering, we refer to the blueprints that we make for these motherboards as artwork, and it's for that reason that a good blueprint is readable, it's symmetric, it's pretty. You color it so that you can understand what signals are where. And so there's a lot of analogs around, well, probably what looks good to a UX designer is also what looks good to a PCB designer on a motherboard in a lot of ways.
Yeah, so you touched on this idea of like, how do you design the user experience of such a tool? I'm curious if you could tell us a little bit more about how the team at Quilter is addressing this, because there's so much going on in regards to laying out a board. And you have this user who typically has a ton of experience. They're themselves a professional. And in many ways, right, that's what we're seeing here in changes to our design tools.
Yeah, so let me first paint a picture of what happens today, just to give us a grounding to work from, and we'll kind of talk about how we see that changing. So circuit board design has three major steps that happen. The first step is called schematic capture. And in schematic capture, you're drawing a sort of a block diagram of what components your board is going to use and how they're connected, right? So you should picture almost like a Figma mock of like, here's like a square that represents my CPU, and it has this wire that connects to this memory, and it has this wire that connects to some power system, and that connects to a USB, and it connects to a screen. And so if you picture like a block diagram architecture, a schematic looks a lot like that. But in our world, a schematic is not sort of just like purely conceptual. It is strictly defined, right? Like you actually count every single it's called a pin on these components, a little physical connection point. You describe explicitly what other pins it's connected to. You leave yourself notes about which wires are going to carry power, which wires are going to carry high speed signals, so on and so forth, right? So the schematic step you can kind of picture like a block diagram or a flow chart, and you'll have some idea of what that looks like to an electrical engineer. And they draw it in a CAD program, but you can use Figma as a decent approximation of what that looks like. The second step is called layout. And a layout is where you convert that schematic into an actual blueprint that a manufacturer can follow to make it real. So at this point, you actually care about like the dimensions of the board, how tall and how wide it is. You care about the size of the chip. You care about precisely where that chip goes. You care about the tolerances from manufacturing. You care about the exact geometry of the wires that connect them. And so you also draw that in what is typically the same CAD system, but a totally different editor. So imagine if Figma had like a mode for block diagrams and a mode for like detailed pixel drawing, right? And you kind of connect the two logically. That's what the CAD systems feel like. And so you're drawing this pixel by pixel, wire by wire, component by component until your whole blueprint is done, right? And then the third step, of course, is to send the blueprint to a fab. The fab makes your board, you get it back on your desk and it catches fire and you learn and then you repeat, right? And so, of course, you see the motivation here is like for us, we focus entirely on that second step. So we kind of view the first step as the electrical engineer's expression of what the board should do logically, almost like writing code is an example we use sometimes. And then the second step of drawing all the details is something that is just trying to make real what was drawn in the first step. So, how do we go about that? Our goal is to save time. Like, ideally, if we can drive that second step to zero, that would be the most optimal, ideal thing. But of course, given limitations of current technology and given information that is only in the designer's head, that's generally impossible today. So we compress it as much as we can, but we still need some amount of interactivity from the user. And when we think about our users, they actually span a really wide range, all the way from somebody who just says, just do it for me. Like I just here's my schematic. The board is not that hard. I trust you guys. Like it'll be fine. Like just do it. All the way to the artisan who cares very much about where everything is and how precise it is and needs control over specific tolerances between different things. And we have to kind of accommodate both because both are very reasonable use cases. So the way that we kind of think about and approach this is to meet the user where they are today. What we don't want to do is throw them into some totally new and foreign workflow that totally, makes no sense. It takes a long time to learn. That's just very painful as an onboarding experience, and of course, gets in the way of the very value we're trying to deliver. So we try to emulate what it's like to work with another person on this task. Electrical engineers often work with a second or a third person to do this layout step. And so the conversation they have is what we try to emulate. But in that conversation, there's some amount of dialogue, right? Like, hey, this wire needs to be really thick because it carries a lot of current. And this wire needs to be a differential pair because it carries a high speed signal. And there's some amount of like pointing at a screen and saying like put this here, rotate that, put this here, and that's kind of like a canvas, like a 2D canvas that you work with. So we currently keep the sort of 2D canvas in the CAD tools they already know, where they impose 2D and 3D constraints, and then we try to read all of their schematics and data sheets to automatically detect all of their constraints and populate that basically into a set of tables that they can review to understand whether we've understood their constraints.
So I'm curious because you talk about helping people to work in an environment that they're used to and they're comfortable with. But one of the things that we've been seeing is that the tools that we are comfortable with are also changing a lot because of the new workflows that AI affords us. So if you take something like Figma, we used to be drawing everything. And then they do have a lot of features like the Figma agent is sort of, okay, we're going to work in canvas mode. But then there was this whole experiment in Figma Make, which was no, it's conversational and it's generating stuff. I'm curious, in the time that you've been operating, have you seen sort of changes to the way in which people want to interact or the way in which your team is saying, like, actually, the future of how you will interact will probably look a little bit different from what the traditional electronic CAD environment looks like today?
I think the answer is both. And it's kind of worth diving into the two extremes, right? if I think about the enterprise, right? Like think of like the Mag 7 and like the kinds of teams they have there for building all their circuit boards, right? We're talking about hundreds of people or thousands of people who are just dedicated to this task of drawing blueprints. In general, we're talking about tens of thousands of electrical engineers. Those folks have not seen their workflow change. The tools they're using, sort of Cadence, Altium, Siemens Expedition, these things, these are 40-year-old, 50-year-old pieces of software in a lot of cases. And of course they're adding features, but not the way that Figma is, right? So there isn't like a day where you open up Cadence Allegro and suddenly there's a chatbot that you're interacting with that like is like doing the thing, like Figma make. Like that's just not the concept for us. Like the features they're typically introducing are we have like a new set of tables in the constraints manager in this one panel that will be super helpful to like accelerate some part of your like process kind of thing. So from the enterprise, and really that's where we focus, I would say overall the answer is no. Like we're not seeing that change. People are interested in what it might look like, but really the hypotheses around what it might look like are coming from the startups. And there's a varying degree of differences in opinion there. So at the startup layer and kind of like the much smaller companies, we're starting to see some of that start to happen, right? So there's some companies out there, not us, but some companies out there that focus on, hey, like we actually shouldn't even draw schematics pictorially anymore. We should express them as code. We should express them as a hardware description language, for which there is precedent, right? Like if you look at how chip design is done and how FPGA design is done, you write what looks like code but is actually hardware description, and then that gets compiled into some hardware actual physical layout. And so some people are arguing that like that's going to be the future of PCB design. We don't take that stance. We take the stance that people are still going to want to see pictorially how their board is laid out, but you're going to get a lot of automation both within the schematic definition and importantly in the layout definition. And there are some kind of new CAD companies that are starting to try to integrate LLMs into the process, but the problem is that large language models are not inherently that good at electronics. Like they're not trained in a lot of electronics data. The electronics data that's publicly available is not that reliable. And so when you just sit down with Claude or ChatGPT and ask it to generate a schematic or ask it to generate a layout, you get very poor results, like laughably poor results. And so people are trying to put an LLM into this workflow naively, but it's just not gonna work, I think, as well as it did for UX design or certainly for code.
There was this point that you made where you're talking about enterprise customers and how like they're not expecting things to change, but then your startup customers are like, oh, they are exploring new processes. How is Quilter thinking about this in regards to learning from startups, but then making sure that enterprise customers are happy? Because I'm imagining that we have a lot of listeners out there who work on B2B enterprise level software. And while they might be thinking of ideas of like, whoa, we could be applying automation in different ways. We could have completely new user workflows based on the automation we can do. We can't just change big enterprise software so quickly. So, how is your team thinking about that?
Yeah, so the actual split is less about a small company with 3 electrical engineers is like trying totally new things, and a big company with 3,000 electrical engineers isn't. What really we see is it's tied more to the complexity of the boards that the electrical engineers design, right? Like a small company with 3 electrical engineers can still be designing something very complicated, like an optical transceiver or something like that, something super sophisticated. And those folks are not trying to vibe code hardware. Like they like laugh upon that idea. On the other hand, we have in our platform, like we focus on enterprise, but we actually do also open it up to to hobbyists and for people to just experiment and whatever. And we've had a lot, like we have a lot of people using it in that framework. And I've had like mechanical engineers. We had this guy who's making parts to tune BMW engines and like knows nothing about electronics. And he's just like, I just need a PCB. I can like do it on a breadboard, but I don't know how to actually make a board. I'll like Google around a little bit, learn how to use KiCad, use Quilter in the loop, and like ship like a little tiny PCB to like help people tune their BMW engines. And that worked. And he's selling that product. And like that's amazing. And so I think that for the really simple boards, the idea of vibe coding your hardware is like people are playing with it. But for anything of real complexity, it's just so far fetched that they're not. And for us, we start with enterprise first. So we're really trying to say very pragmatically, what does it take to do a serious motherboard? And then how do we inject automation in there? And then as our users are using it, what else can we learn? What else can we alleviate? With the key still being, how do we maintain their control and their insight into the reliability of the board?
Can you say a little bit more about maintaining control and insight and how the team is designing interfaces to help with that?
Yeah, yeah. So I think that the first thing to consider here is that the way we approach this is different than most kind of like large language model applications. So, I mean, first things first, Quilter is not a large language model, period. There's no OpenAI call, there's no Claude call. Y- As I've kind of already mentioned, you can't just ask one of these large language models, please make me a nice layout, pretend you're an expert designer. Like, that's just not going to go well. But furthermore, the philosophy of how LLMs are trained, we think is also not applicable. What an LLM fundamentally does, like at the first training pass at the core, is take a block of text, cut it halfway through, from the first half, predict the second half. And if you get really, really, really good at that, you get all of the magic that we get today, right? But what you're really doing is you're saying, in this context, what would the human do? And for a lot of applications, that's a very reasonable approach. We think for PCB design, it is not a reasonable approach. Because, I mean, if you get it 99% right, then you still have 1% mistake somewhere, and that kills your whole board. That's for one. For two, well, how do you know the human you trained from got it right? And also, that human spent 3 months to design a motherboard. They didn't have time to optimize it. So you hit a very theoretically non-maximal kind of ceiling with that approach. So what we do is we approach it from physics first. The core statement of the company is that whether or not a PCB layout or design is good is computable. If you can compute from a electromagnetics and thermodynamics perspective whether or not it's a good design and give it a real threshold of like, here's how much margin it has, here's the performance it achieves, then you just optimize that signal. So everything is built around that principle. So when the user is communicating to us about their design, they're really telling us, here are my requirements. Like, this net has to carry 10 amps. This thing is 100 volts. This thing is 1 gigahertz, so on and so on and so forth. And then we set up very explicit checks for whether or not the layout we've created accomplishes that. And we very honestly tell the user in a big report, here's what worked and here's what didn't. And our job is to make an optimizer that can satisfy all of that. And the user's job is then to review the report and judge whether or not that work is useful to them and whether or not they want to fix all the stuff that we didn't get right and keep the stuff that we think we did get right. So the key is to start with the physics and to quantify how well we did our job, not just blindly copy humans.
Yeah, this actually is making me think there is a sort of AI house style that we've talked about on the show before, where like any vibe coded site, at least any naively vibe coded site or an interface, is like it kind of has the same look. And partly it's because of the systems that any of your LLM provider is giving you with like a design MD file or just kind of what is sort of the zeitgeist. But I think you've raised a really good point about how this is basically what would a human have done, but did the human do a good job? And honestly, we have a lot of bad web design or a bad product design that's out there. And so why should I just do what everyone else does? The other thing I wanted to maybe just follow up a little bit on, how good a PCB is can be computable. And this is something where I'm trying to think of what other areas of design are like this, and then where is it not like this, and how do we approach that? Arguably, I totally understand how a PCB can be a computably good board. But then let's say your team designing the interface and the interaction that the user has, I'm not sure if that can be computably good. But so still then how do we work on that?
Yeah, I can't imagine a way to compute whether like a product UX is good. Like, that seems impossible to me. I mean, maybe I'll eat my words one day, but that doesn't. I don't see a way to do that. I think that at least the way that we approach it is, and the way that we leverage, AI tools within our own company to approach is that the source of truth is our customer. We observe on our free tier, lots of people using the thing. And we observe our enterprise customers that we are supporting and teaching to use the thing. And all the things that we thought are obvious are totally not obvious. And vice versa. They find tricks that we didn't expect. And so we learn, right? And so, okay, I don't have a heuristic where I can replace that. There's no pip install human dot evaluate. That'd be nice, but that's not a thing. But but we have plenty of customers who are very willing to tell us what they think. All we have to do is listen and iterate. So the key for us is, how do we shorten the iteration cycle? How do we ship something, get feedback, learn, and ship the next thing? And, on the enterprise side, it's a little bit harder because you have to go through security, you have to go through controls. Some of our customers do boards that fall under security clearances or ITAR. I mean, you don't just like screw around with that. That's hard. But on our free tier, we actually learn a lot about exactly this question. People come to us and they throw boards at it and they speak to our intercom or Fin bot and they tell us exactly what they think. And we look at their inputs and we look at the outputs they achieved. And we think, oh, well, we could have done that better. But of course, we could have. We know our tool. What did we not make obvious that prevented that? And for that reason, sometimes we ship to production multiple times a day. In general, there's this principle in software engineering of continuous integration, continuous development, and the companies that do it exceptionally well, like I'm thinking of Stripe, they'll ship to production sometimes dozens or hundreds of times a day, where whenever an engineer makes a code change and they verified it and all the tests pass, it just ends up in prod a few hours later, and you immediately see the response, right? And to an extreme, you could even A/B test that and whatever else. We haven't gotten to that level. We're a 40-person startup. Uh, but we still take that ethos of ship and just see what happens. And like we have a Slack channel of all the feedback we're getting from Intercom. All of our engineers see it, and all the time we have discussions there about like, oh man, this user's struggling with this. Like this merge request is going to help them, or this thing we're talking about we should accelerate, or hey, like this thing is about to ship, like we should speed it up, whatever. And so I think the best we can do is just iteration cycles. Get your product out there. One of my early leaders used to say that the sunlight is the best disinfectant, like 100% true. Get it out there, let people very easily try it, let people very easily tell you what they think, and just ship, 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 and be okay with the fact that you're going to ship some stuff that's substandard and you're going to iterate on it.
Uh, a nice tie in here. We actually had Tom Rimmer, who's one of the lead designers of Fin, on the show a couple of weeks ago, and he told us a lot about the processes and the way that they're working in their team. So it's cool to hear you mention them. But actually, the connection that I'm making there brings up a question for me is, so you told us a little bit about how you're getting feedback, you're working with that. What processes have you and the teams put in place to kind of manage all this stuff? I mean, is it mostly like we're a 40-person startup, we can be super dynamic? Do you have AI systems that are helping your teams? How are you working differently to actually move this quickly?
The way I personally think about this is that AI in general, and even just large language model application to code and to everything else, is super early. Super, super, super early. Whatever your favorite expression, the first inning or whatever. So to lock in a process or some opinion, I think would be foolish. I think that you should optimize for exploration. So, for example, we let our engineers use whatever model they want. Some people use Codex, some people use Cursor, some people use Claude, some people use, I mean, just whatever, Windsurf, like just go for it. Yes, the answer is yes, go try it. Uh, we obviously have to have security in place, right? So we make it easy for people to do it the right way. So with every one of these accounts, we set up a Quilter dedicated account and it has the right permissions and controls. And we're SOC 2 certified, which means that we apply the right standards to all those connections. But we encourage people to make it as easy as possible. Now, the next thing we do is we encourage people to share how they're using it. And people are using AI in very different ways. I have people who are all the way in the spectrum of just like, man, I'm going to use it for everything. And people who are like, I don't want to use it for anything. I still don't trust it. I don't think it does this section of my job well enough. And like, this thing is not good enough yet. And I'm going to do it by hand. Like, we have the full spectrum. But the way that we kind of encourage everybody to find useful things is just to talk a lot. We do an all hands every Monday, and we like to do demos of like, hey, like, what did you accomplish with one of these things and what worked? And there's a few things that have been surprising and interesting. Uh, so, for example, I mean, obviously, everybody by now uses it to some extent to write code, and in different versions of that, that works really well, and so on and so forth. That's fine. The more interesting things that are more surprising than that is like I had an engineer do project planning with it, where they would actually connect to Linear's agent or use Linear's agent directly and like set up a project, set up milestones, set up tickets, like what are the right questions and whatever else, and just like converse with it until the project plan made sense. We've had people automate entire subsystems, for example. Like we have this thing where we have to very closely integrate with the existing CAD systems, and that's really, really hard. And instead of just sitting down and writing down step by step every single thing that we need to read from those files, we had engineered just set up a loop where it tries to run that program, it tries to evaluate what came out of it, it evaluates how that compares to another source of parsing. It just develops the entire code base to like replicate that parsing. We try to use it for reviewing code as another example. So the important thing here that I'm kind of getting at is that whenever somebody tries to use it and either learned a way that works really well or a way that really failed, talk about it. And then that inspires other people to try to do the same thing or critique and try to improve that process.
So, in talking about these ways of working, I like the fact that you're being super experimental about it. I mean, as an educator, this is also what we're doing a lot of. Like, I'm having students just try things. And actually, this idea of sharing what they learn, like what works, what doesn't, we're doing this in my class to try to get people to share because actually, I don't know. No one really knows the answers of how all this is going. Actually, we have a number of students who listen to the show, and I'm curious, right, from the CEO perspective, what are you looking at in regards like when you're hiring people now? Does AI usage come into play? Does understanding how to be effective with these things shape who you're looking for? I'm curious on your thoughts there.
Generally, yes. It's not. It's certainly not the most important factor, but it is important. You know, when we hire, the main thing, kind of the simplest thing we're looking for is what's something impressive that you've done. Just like very simply put, right? My background before starting this company, I spent 5 or 6 years at SpaceX, and this is very much the way that SpaceX approached things. It kind of matters less whether or not what you've built in the past is relevant to what we're doing, but it does matter how impressive it is. Is it hard? Like when you explain it to me, do I think like, oh, come on, man, that's like a weekend project, or do I think, wow, how did you do that? And then I end up asking you like an hour's worth of questions. Of, how did you do that? Like with me personally, the interview process is tell me about something cool. I get really curious. I bombard you with questions. And if you go 3 or 4 levels deep on the why, you're going to pass. And if you're kind of like go 1 or 2 levels deep and we find out that really somebody else did it, or you just kind of like vibe coded it, nothing happened, that's not curiosity, in my opinion. That doesn't work. Is AI tool use important? Generally speaking, yeah. Because what we do now is, especially in our technical interviews, we give you a problem that is so laborsome to solve by yourself that you're just not going to solve it in a reasonable amount of time without AI tools. And we do that for kind of two reasons. One is that, well, for one, we're actually just trying to give you a problem that very faithfully represents the kinds of problems you're going to solve here. So if you're working on that problem and you're like, man, this is so boring, like I hate this, that's fine. Like you shouldn't work here. Like you're not going to like it here if you don't like this kind of problem. And for two, we expect pace. We expect you to solve a problem of that magnitude in that magnitude of time. And realistically, the only way you're going to accomplish that is if you're pretty decent at using the tools already. You don't have to be like the world's greatest expert or whatever, but like if you're not using them at all, it's going to be a slog and you're just not going to perform well.
Yeah. Okay. This is super cool to hear because I think that I have been excited about the ability for these tools to actually accelerate what we're able to accomplish and actually for people to realize ideas that are a lot bigger than what they would be able to do otherwise. This is something we talk about a lot in my class and that I'm push students to do it. So it's cool to hear from your perspective how you're sort of looking at that. I guess maybe one more question. I'm curious, like, is there anything that, you want to talk about or that I didn't ask you?
I mean, honestly, well, it could be fun even just to brainstorm is like, even within Quilter, what should the UX be? Because like if you think about it, there's kind of three at least three options that I can imagine. And what we're talking about here is this interesting problem where in order to compute whether a circuit board is going to function, you need to collect the context. You need to understand for every pin of every component precisely what signal in terms of voltage and current is running in that pin and what is the requirement for how it has to arrive at the other pin. So if you have a 5 volts on one pin and you run it through a very bad trace and it ends up on the other side as 4 volts, that's bad. Now the other part is going to brown out. So maybe the requirement is that 5 volts is allowed to drop to 4.8 volts. But we have arguably thousands or tens of thousands or more of these constraints to express. And For a human to sit down and manually make a table of 10,000 constraints, like that's just no, like nobody's going to do that. That's horrible. You'd rather just draw it yourself, right? That's not going to work. So how do we express that, approach that, and how do we allow the human to review that volume of constraints to not miss any one of them and to do it in a reasonable amount of time? And roughly speaking, I see maybe three different course approaches. Like the in vogue thing now is, hey, you get a chat box, and the chat box spits out text and it tells you what it thinks, and then you talk to it and like blah blah blah, right? Like hypothetically, maybe Quilter could work like that, where like you've dropped in your schematic and we just bombard you with a chat box worth of questions. Maybe. The paradigm we currently have, just because it was the simplest to build, is a lot of tables. And you're like, okay, I want to go to my power system. Cool. I already have defined a group of my wires that need to have 10 amps. Okay, let me like manually bring them in, check them, verify the table. Laborious, reasonable, but laborious, right? And like a lot of our users will even, we built a little feature where they can just like dump that into Excel, and they'll prefer to actually come back to Excel, a tool that they're very used to, and like review it there and like modify the numbers and like re-upload it into Quilter, which is like fine and great. Excel is the single greatest engineering tool on earth, but something's not right about that. And then the third, and a hypothesis I've had that I haven't validated, is as an electrical engineer, the thing that I know best, like the thing that I could draw in my sleep that I have nightmares about or dreams about, is my schematic. Like if you picture it as a designer, an early architecture block diagram, you know exactly where every box is and what the title of that box is, and what color the arrow is between them, and how far apart two arrows are. And you could draw it on a napkin in your sleep, like easily. So if you know your schematic that well, you also know where all these constraints are with respect to that schematic. And so maybe we should actually show you a picture of that schematic and let you like select things in it and draw constraints that way. And like, that's a good starting point because you know your schematic really well, but you don't get that nice flat list of things that you can kind of check off and exhaustively go through the way an engineer is used to. And then the other thing is you also don't want to force the user to do all of this at once. In general, engineers like to throw something in, click next, 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 see what happens in the end. Be like, this thing is garbage. Let me go back and like fix that, and then iterate, which is fine too. But maybe that means you actually collect some of this data after you've done the first pass, and you're asking the engineer, okay, looking at this actual layout, what's wrong? Oh, you wanted to constrain this. We can do that way over here, right? And then you factor in an iteration loop. And we don't know the answer to this, but it's super interesting and not obvious of what this is going to look like.
Yeah, I mean, there's a lot of explorations that we've done in my group, and then a bunch of other HCI groups have been doing around what are actual better AI assisted workflows for different types of applications. I mean, the standard sort of throw a chatbot in is kind of what we're getting, but it's often not the case, especially when you're working in visual interfaces, when you have stuff that's tied to specific aspects within like a laid out visual, like a schematic, or honestly, even within UX design stuff. I mean, this is why I think Figma is working really hard to do something like, say, the design agent, because people, they understand their board, they understand where something is in the interface, and they want to be working within that. Having just the sidebar isn't really enough. But I don't know. I think we need more experiments and explorations in this. One other question that I had that this brings up, because we've explored this a lot in our research regarding AI support for engineering designers, is how much are you thinking about the AI also backing up the designer, or sort of acting as this co-collaborative partner as opposed to just an automated agent? So you had talked earlier about how, oh, it's like talking to someone else. And actually, when I'm sitting down talking to someone, they might say like, hey, you got to think about the signal that's going through there, and like there might be interference on these traces. Like we should probably think about this or whatever. And an engineer might go, oh yeah, I hadn't really thought about that. Actually, how would we change that? Does that even change, say, something I might do upstream in my design? We have these kind of conversations all the time in UX. I'm curious, is Quilter right now exploring that? Are you doing any of this, or is it mostly about sort of the automation at this point?
Quilter right now, no. I think longer term, there's potential for this, right? As a 40-person startup, the number one thing you have to do is focus. So, like, the most important part of my job is to say no to 9 out of 10 things, and like really, really, really drive home like the one thing that like is helping people today. So, for the sake of focus, we're not doing that today. Like, you've given us an input, you've given us constraints. Our job is to meet that to the best of our ability, and that's it. And to the extent that which people are getting a sort of useful dialogue out of Quilter, it's self-driven. And I'll give you one example of this, right? Like we had a bunch of customers do this where they'll take a board and they say, I don't know how small I can make it. Like I want to make it as small as I can because it's cheaper and whatever, but I don't know how small it's going to be. And if I make it too small and I spend a week or two drawing the blueprint and I find out I made it too small, oh no, that's a disaster. I have to make it bigger and I have to redo the whole thing and I lose 2 weeks. And so you conservatively guess. And so what people do with quilters, they're just like, okay, let me try 3 different sizes and see which one quilter solves. And so there's a little bit of that dialogue, but we're not making it easy or obvious to do this kind of thing. You have to do that as an engineer. Now, there's a very natural place for us to go, which is like, hey, you've given us a schematic. You've given us all this information about it. We should critique it. Like if you accidentally connected a 5-volt pin to a 3-volt pin, we shouldn't just blindly lay it out for you. We should be like, hey man, like this looks wrong right here. You should check that out before you go on. So I think that that potential is very much there for sure. But for the sake of focus, you've given us a set of constraints. You've given us a schematic. You're the human. You know best. We'll do our best to do exactly what you say.
Okay, that's super interesting because I think right now what we're seeing in the UX world, or especially when people are doing interface design and they're laying things out, sometimes the systems are getting a little bit more proactive. They're sort of starting to make suggestions. They're saying, "Hey, have you thought about this?" They're asking questions, and I can imagine very similar things in regard to this, especially because the fact that some of the stuff that you're doing potentially even has better opportunity to do that in a really rigorous way. Because if it's physics driven, you really do know something and can take something, say, provable about the design. Whereas if I'm creating sort of a web interface and it's like, hey, have you thought about this user? Have you thought about like, oh, wouldn't it be nicer if you did this? And you're like, well, you don't really know what I'm doing. You're kind of just making something up. Whereas in your case, it could actually be, yeah, much, much more tied to something that's real.
I totally agree with you for what it's worth. It's just a matter of time. Like I wish I could build all the cool ideas and things that we have, right? I really do. But at the end of the day, I'm still bottlenecked by like hiring engineers, and I hope they use AI tools to go faster, but I still don't have enough of them. And if I did, then I'd try more of these things. But we have to be very careful with what battles we pick to fight because each one of these things is super hard. This PCB layout problem is really, truly, brutally difficult. And you can't kind of solve it 80% in a bunch of places. That's going to be a very bad product.
Yeah, it's nice actually. The level of discipline that you're talking about sounds in some ways refreshing because one of the things that I'm actually starting to almost get a little worried about in other spaces is the fact that when the tools make it so easy to create basically any new interaction, any new interface, and code is, well, we used to say code was free, but now everyone's saying like, well, code's really expensive now. We got to watch our budgets. But when effectively it doesn't cost much to do, I feel like you're going to start seeing sort of feature enhancements, but also potentially a lot of feature creep. And wonder, it sounds like you're basically taking a very disciplined approach there. But I could also imagine someday when you have a bunch of agentic software design and engineering processes, you start just adding, whatever customers ask for, because in theory you can. Beyond just the we're a startup and we're being disciplined, like how else might you think about and might you recommend to like design teams who are out there how to stay focused when you could build whatever you want?
Yeah, it's a really good question actually. I mean, I think I'll give you a couple of thoughts here and then maybe we can go into the pragmatic side of how to make it happen. Like there's this like concept in design that's always been true that maybe we're forgetting a little bit, which is that perfection is not when you can't think of anything else to add, but when you can't think of anything to take away. And like we can use AI to discover that, but it's not by just bolting things on without end, right? Like one of the things that we used to say at SpaceX all the time is like you should be deleting things from your design so much that at times you have to add things back. And the cue is that if you never find yourself adding back something that you just deleted, then you're not deleting enough things by definition. Like you should overcorrect on deleting to the point where sometimes things have to come back. Otherwise, you're not deleting enough. And the feedback we get from our customers about this is very explicit. A lot of our customers do look at other companies that tackle variants of this problem, and they tackle it in the kind of more LLM, throw features, do everything, overpromise kind of way. And that word you said about what I was saying, refreshing, we hear that on our customer calls. Like I've got dozens of gong calls of people telling us, man, this is so refreshing. Like, thank you for telling me your limitations. Thank you for telling me you don't do a bunch of things. refreshing is precisely the word that's used. So I think that as the world gets saturated with agentically bolted on features, those companies and those designers that stand out in their simplicity are going to float to the top. And so the question is just how to make that happen. I mean, I think maybe there's a few things, right? This idea of like delete so much that you're adding back is a good heuristic for sure. I think the other one is don't design by committee. Like pick an entire user story and like one person's responsible for it, even if they have to span across teams and learn a bunch of stuff they don't know. Like that is much better than a bunch of people coming into a room because people are nice. Like if I have an idea and you have an idea, I want to say I like your idea and you want to say you like my idea. And so both our ideas end up there and then we kind of compromise weirdly. Like that's horrible. And I don't want to be not nice and tell you your idea sucks or hear that my idea sucks. So how do we avoid that? Make one person responsible for as much as they can so they keep it cohesive. But again, I think sunlight is the best disinfectant. Show it to your users, listen to them. And if you're not hearing them like grab their credit card and shove it into your hands, it's not good. They tell you it's nice, but if they're not like begging you to take their money, it's not nice. They're just being nice.
All right. I think this is actually a great place to end in regards to some suggestions that people can take. Sergiy, thank you so much for being on the show. This was great. I had a lot of fun. I feel like I actually learned a lot about maybe how to think about running projects in the future. So that's our show for this week. Thanks for listening in, and we look forward to having you join next week for some more news, topics, and awesome guests on AI and design.